Hello everyone, welcome back to my channel. In this video, I want to show us the easiest way to solve this simultaneous equation. Okay, solution. Alright, so we have a plus b equals 1 and we have a squared plus b squared equals to 3. Alright, you know that a squared plus b squared is equals to a plus b squared minus 2ab. Okay, when you use identity of square, remember that when you have a plus b square, when you expand this, it's going to give you a square plus 2ab plus b square, and then by the time you take a square and b square together, then it will give you a square plus b square equals to, you subtract 2ab from this, which will give you a plus b square minus 2ab. Okay, alright, so that is what I have written here. And then you know that our a square plus b square is 3, while our a plus b is 1. Okay, so it means that a square plus b square is 3. I'm going to write 3 here, equals to, what is our a plus b? A plus b is 1. 1, we have square minus 2ab. Okay, this is 3 equals to a square is 1 minus 2ab. All right, so by the time we move this to this side, so we have minus 2ab equals to 3 minus 1 will give us 2. And then from there we can find AB. So it means that AB equals to 2 divided by minus 2, and that gives minus 1. So our AB is minus 1, and then remember that our A plus B is 1. Okay, so our A plus B is 1, while our AB equals to minus 1. Alright, so it means that anywhere we see AB, we write minus 1, and when we see A plus B, we write 1. Now the question says we should find A raised to power 5 plus B raised to power 5. So we have to find A raised to power 5 plus B raised to power 5. That's what we are looking for. And then how to solve this, we have to use reoccurrence formula. Okay, so using recurrence formula, using recurrence formula, and then in recurrence formula we say let Sn equals to a raised to power n plus b raised to power n. And then what is our Sn? Our Sn is is the sum of the nth power of the root of a and b. Okay, so that's what Sn is. And then we can also derive the identity. So the identity is going to give us, we have this as the identity, we have the sum of the nth power of the root of ab is equals to a plus b Sn minus 1 minus ab Sn minus 2. Okay, so that's the formula when we use recurrence formula. All right, so from here we have our AB. We are given AB to be 1, and we are given a squared plus b squared equals 3. Okay, our a plus b is 1, and that represents our S1. And then we are also given a squared plus b squared to be 3. That represents our S2. Okay, so for us to find the sum of the fifth power, all right, so we need our S3, we also need our S4. Okay, so now for the sum of the fifth power, the formula is given as a plus b Sn minus 1 minus ab Sn minus 2. Okay, that's the formula. Then for the sum of the fifth power, anywhere we see 5 here, anywhere we see n, we're going to write 5. So we have a plus b, 5 minus 1, this will give us 4. Then we have ab, 5 minus 2 will give us 3. Okay, so it means we need the sum of the fourth power of that root a and b, and we also need the sum of the third power of that root a and b. So, and then we are only given the S1 and the S2, we need the S3 and the S4. So it means we have to use the same recurrence formula to find our S3 and our S4 first. Okay, so let's find our S3. What would be our S3? Our S3 now is going to be A plus B S2 minus AB S1. Okay, that would be the sum of the third power. Now, what is our AB? Remember that our A plus B is 1, so we have 1. What is our S2? Our S2 is 3. Okay, our S2 is 3. This is 3 minus, what is AB? Remember AB is minus 1. And what is our S1? Our S1 is 1, because then we are giving A plus B equals to 1. So our S1 is 1. Okay, so finally we have 1 times 3 is 3. 3, and this will give us plus 1. So it means S3 will give us 4. Okay, now let's look for our S4. Let's look for S4. Now, S4 is also A plus B S3 minus AB S2. Okay, using the recurrence formula. All right, so what is our A plus B? A plus B is 1. What is our S3? Our S3 is what we just calculated, which is 4, minus AB is minus 1. What is our S2? Our S2 is 3. Okay, our S2 is 3. So 1 times 4 is 4, and this is plus 1 times 3 is 3. So it means our S4 is 7. Okay, now that we have our S3 and we have our S4, we can now successfully find the sum of the fifth power of that root A and B. And then I'm going to write the formula again. Our S5 now is going to be A plus B S4 minus AB S3. Okay, so now what is our A plus B? A plus B is 1. What is our S4? We just calculated it, 7. Then what is our AB? Is minus 1. What is our S3? Our S3 is 4. We calculated it earlier, is 4. Okay, so now we can multiply. This is 7 plus 1 times 4 will give us 4. So it means our S5 is 11. Our S5 is 11. Therefore, A raised to the power 5 plus B raised to the power 5 equals to 11. This is our final answer. Okay, all right. So I think this is the easiest and the fastest way to find A raised to the power 5 plus B raised to the power 5, which is 11. All right, so now let's try to solve this. I'm going to give us the same equation, okay, but I'm going to change the sum of the nth power of the roots. All right, so let's try this. If A plus B equals to 1 and A squared plus B squared equals to 3, okay, the same one, then we are going to find A raised to the power 8 plus B raised to the power 8. Okay, so that's the only thing I've changed. Now let's try this and write our answer in the comment section. Alright, thanks guys. Don't forget to like, comment, share. And if you have not subscribed to this channel, please and please do subscribe. See you next time.